Welcome. Thank you to the afternoon session. I hope you've all been fed and watered. And we're going to talk about sustainability today. So my name is Nick Crew. I'm from Airbus Defence and Space Division. Airbus, as you know, covers commercial aircraft and helicopters, and sustainability is a big topic for us and part of our roadmap. I also a COO of an initiative called Airbus Endeavour with the Welsh Government, where we are partners in commissioning research in our region. I'll now let the panel introduce themselves. So Ffion.
Hi everyone, so I'm Ffion and my background is in aerospace engineering and I graduated just over a year ago now. And since then I've been working at Oshen, which is a small startup based in North Wales. And we're building these micro vessels we're building to go out and collect data in the remote oceans. They're wind powered, solar powered and fully autonomous. In the last year and a half, we built 2 functioning prototypes and they've collected weather data and biodiversity data. And our microvessels use satellites for communication, so we can track them, we can tell them where to go next, and we can collect the data over satellite. And this ocean data is really important for a whole host of reasons, from monitoring marine life to modeling climate change. And right now, a lot of this data actually comes from satellites. So we want to use...
We'll come on to more of the detail later, but Ffion, welcome to the panel. And Jeremy, just a brief introduction about yourself, where you're from. And for those in the audience, if you can't hear the microphone very well, there's some headsets, I think. Yeah.
Okay.
Jeremy, brief introduction.
Thanks, Nick. Yeah, Jeremy Howitt. I'm from Snowdonia Aerospace. We run the Snowdonia Aerospace Centre up at Llanbedr in northwest Wales. And it's also the only UK spaceport that is based in Wales. So we're looking at a whole portfolio of novel aviation-based research and testing, and some very interesting links into space observation that we'll be touching on later this afternoon.
Great, Jeremy. Thanks very much. And briefly, Andrew, just your name in rank.
Thanks, Nick. Yeah, Andrew Bacon, CTO and co-founder of SpaceForge. We are a satellite manufacturing company based in North Cardiff in Rumney, and we are specifically building new generation satellites that go into orbit, manufacture new materials that you cannot make on Earth and bring them back to Earth. And particularly the reason why we're here today is we're really focusing on markets where those products can really help us reach net zero goals.
Fantastic, Andrew. Thanks very much. So sustainability then is quite a buzzword, I guess, in the industry. Put it along with other words, but what does it really mean to Wales? What does it really mean to business, and what does it really mean to people itself? So, if I can just ask a bit of perspective from our panelists. So, Ffion, your perspective and the intersection between space and sustainability.
Yeah, so I think that collecting this ocean data is really, really important for a whole range of reasons. We want to track weather forecasts, model climate change, and yeah, right now a lot of this data comes from satellites, which is really great. They cover large areas, and our idea is that we can launch a fleet of our autonomous microvessels and use them as data points to help improve the weather forecast from satellites and improve the accuracy, and to have a real in situ data point that will validate these measurements.
Can everybody hear Ffion okay? Oh,
sorry.
And Jeremy, from your perspective, sustainability, what does it mean to aerospace?
Yeah, I guess we're sat here on the net zero stage, and I'm not going to talk about net zero in any shape or form. Our view around sustainability is a much more holistic one, based on where we are, our input into the space industry, the space program in the UK, but also based very much around our physical location within Wales, within Snowdonia National Park. And for us, that really starts with Snowdonia Eryri being one of the biggest and best dark skies reserves in the UK. And the importance of dark skies to not only human health and well-being, but also that of the flora and fauna within the environment around us, and the opportunity that presents to be able to support history, culture, heritage, and language, looking back at where we've come from, but also looking forward, and the opportunities it then presents for education, for skills development, and the creation of local jobs, and then using that as a focus then to reach out and create a research environment that links with the wider Space Wales community, and some of the fabulous work that's being done by the various organisations, some of which obviously are represented either side of me on the platform here this afternoon. So one of the things we're looking to do next, alongside the space testing engineering work that we're doing, is to develop a space discovery centre. So one of the things we found, you look at Wales, you look at what excites people. Space and dinosaurs are the two things that kids get really excited about. But there is no observatory in North Wales. There is no planetarium in Wales outside of Cardiff. There is no facility that combines a planetarium and observatory anywhere in Wales. So really, if kids in Wales want to learn about space, they have to travel to England to do that. So we want to solve that. We want to create a space discovery centre that sits alongside the spaceport, that links with the dark skies, that allows us to tell the stories of the skies our ancestors used to see, the Celtic gods in the sky, and links that then into education opportunities and a research environment around that. And Nick's moved closer to me, and I know there'll be lots of questions that will come from that.
It's very broad, Jeremy. Thank you very much for your perspective. Just handing over to Andrew briefly the microphone. Andrew, your perspective from your business in terms of sustainability, what does it mean to SpaceForge, do you think, summarising?
So net zero is an extremely hard thing to achieve for a company, for a country, for a planet. It's probably the hardest challenge that we've ever faced as a species. So with every really hard challenge, you need multiple approaches. You need multiple ways of solving a problem to help reduce it together. So we're already kind of doing the thing. You look around the exhibition here and you see there's a lot of work being done on recycling, potentially carbon capture. These are all good approaches, and moving to greener energy sources. But there's obviously there's an extra aspect to it, which is one we're focusing on, which is making our systems more efficient so we don't have to consume the same amount of energy and therefore produce the amount of CO2 in the first place. It's kind of a double whammy, because if you can make something more efficient, you can make it smaller because it has to deal with less heat, and it's usually cheaper because it's less, you don't have to carry it around as much. And then you're using less energy, which is not only saves cost, but also means it easier to convert our energy infrastructure. So we're really focused on making things more efficient. Now, how do you make things more efficient? Well, if you look at some of the most energy-consuming industries today and going into the future, where we're going to be using most of our power is one of the big things is obviously an aircraft. We're moving to electric aircraft. We've already made the move to electric cars. And a lot of the energy in those are lost inside the power electronics. So there's a lot of work being done to be able to make the electronics inside the car more efficient. And so this is really a lot of the electric cars you see, 20-30% of the power can be lost in a square centimeter of material. So if we can make that tiny little 100 milligram material more efficient, we can make it better able to handle the heat, then we can save a lot of energy in that car, make it faster to charge, and it uses less energy in the first place. So SpaceForge, we have the proposition of using space to make more efficient semiconductor materials. Why does that help? So if you go into space, what have you got? You've got microgravity, and semiconductors are crystalline materials. And we've seen from the last 20, 30 years of experimentation in space, all the way back to Space Lab, but much more so on the International Space Station, that anything crystalline grows better in space. Also, you have this abundant access to free ultra vacuum, something which on Earth you need multiple stage vacuum pumps to achieve. In space, you just open the door and it's there for free. So combining these two attributes, you can make better semiconductor materials, which only weigh, these hundreds of milligrams each. When you bring them back down to Earth, you can put them in a car, make it more efficient. So that's how we can save huge amounts of CO2. And we've theorized if you're putting the semiconductors we're making in space into the car charging infrastructure that's being deployed today, over the next 5 years, we could save more CO2 than the whole of Belgium because of the amount of material being used. So this is the proposition of Spaceforge and others moving to space to use space as kind of the best factory environment available to humankind and then use it to benefit people down on Earth.
Fantastic. Thanks very much for that perspective, Andrew. Jeremy, just back to you on the dark dark skies. How's that link going to work from sustainability from a business like Spaceforge and what you're looking to do?
Well, I think we were talking about this backstage beforehand, and one of the things that Andrew really needs is skilled engineers. Not just his company, but actually the whole space industry in Wales. And so we're starting at the very beginning of that journey. And it's, as I say, it's really about getting kids interested in space, providing opportunities within Wales to learn about space, to be educated in space, and then to stay within Wales and earn a living out of that.
Yeah, so sort of good sustainability agenda, meeting the skills agenda. Ffion, can I just pass over to you? Wales is surrounded by water, isn't it? So, I mean, is this the inspiration for your business?
Yeah, definitely. We need to be near a big water source to test our boats. It's also really windy, which is really great. We can take our vessels out into the Irish Sea, just out of Carnarvon, testing quite rough seas, actually. And also the water's got really high importance biodiversity in it, which is important for marine mammal monitoring, which we've been carrying out the last 6 months. And it's actually something that satellites can do as well with their imagery. So I think that link and having the ground truth, like we were saying earlier, is really important to link them up together.
So can you tell us a little bit more about the business model that you have in the company?
Yeah. So right now we're building prototypes. We've got them out on the water. They're collecting data. And our idea is that we'll sell the data. So we'll keep our micro vessels, we'll operate them, we'll tell them where to go, and then we'll sell this data. And main uses are to go into improving weather forecasting and climate change model. But the last 6 months we've been also doing biodiversity surveying, so tracking marine mammals, seeing where they're going. And I think Andrew was saying it'd be great to have some ground truth on when they're bringing their satellites back down into the sea, and actually having one of our micro vessels there collecting real-time data and sending that over satellite every 5 minutes would be really useful for that.
Thank you very much, Ffion. Coming back to Spaceforge in the launch, I mean, do you have any concerns about launch in general? Andrew, do you want to?
Yeah, Spaceforge, we have an ambition to be a carbon negative company. And of course, the initial thought, and I could probably read that on some of your faces, is like, how can a space company be carbon negative? Because you're launching rockets, and that's obviously you're burning a lot of fuel. The perspective is, if you take an average rocket, the size of a Rocket Lab's Electron, which can launch 150 kilograms into orbit, that burns about 8 tons of fuel in the space of 10 minutes, which is a lot of fuel. But actually, that's about the same amount of fuel as an average family car burns in a year. So the difference between a rocket and your car is it burns that fuel a lot faster. So, no, but that doesn't get us off scot-free, because you're dumping, you're generating carbon higher up in the atmosphere, which does have additional forcing effect on the atmosphere. So it's not great. There are lots of companies, launch companies now looking at this. So there are a couple of companies, particularly Sky Aurora and Orbex up in Scotland, who are looking at more green fuels. The issue is not so much the actual burning of the carbon itself, but it's more the black soot that gets generated has more of an environmental effect. Now, we as a company, we are tracking all of our CO2 that we've expended to date. So we have a CO2 tracker which has been counting up since we started. It's our 5th anniversary as a company this month, and we've tried to calculate it since we started. And we're going to continue to do that because we want to know it's going to keep going up as we expend it, designing and building our satellite, because there is a lot of CO2 associated with that. And there's probably more in the design and build of the satellite than there is in the launch of it. But then when we are launching satellites, and we've got our next launch early next year that we're building for right now, when we start bringing the products down, we're going to start accounting for the fact that we're going to be replacing, say, the power amplifiers inside 4 or 5G towers. And those towers, we can make them maybe 50% more efficient. And they're burning kilowatts of power every day, 24 hours a day, for 10 years. And when you add that up, that's tons and tons of CO2 over the year. And we can make enough semiconductors to support thousands of towers every go. So actually, we have this claim, which we've done a lot of numbers on and had it backed up, that for every kilogram of CO2 that we expend, our products when we brought them back to Earth, they'll be saving around about 10, 20 tons of CO2. So you really can get that kind of massive multiplier by manufacturing in space. So yeah, you've got to look at the full life cycle of a product. But yeah, it is possible for a space company to be carbon negative.
Very interesting. And Jeremy, just to hand over to you, I always thought Llanbedr in Snowdonia Aerospace was going to be a launch pad. What's changed, and what's net zero mean for you?
I'll take this first question primarily. Our heritage has always been in test and development. And I think that's what always sets us apart from the other spaceports in the UK. Actually, our ambition, while I would say it was never orbital launch, we always saw that as a secondary side to the developmental activities. So there's actually a huge space business in the UK for which launch is obviously the ultimate goal, but is only really the tip of the iceberg. So our business is really about supporting that vast bulk of the iceberg in terms of the research and development and testing that's necessary to get you to that point, using the facilities at the airfield and the test range out over Cardigan Bay in order to develop those activities. In terms of supporting net zero and sustainability, we're supporting other companies in their development of alternative fuels. So that's one aspect, and really providing a range of test capabilities from ground-based all the way up to near space that really allows them to reduce the risk before they actually need to go to orbital launch. So before the last thing you want is to go for a launch, put something in orbit, find it doesn't work, and then you realise you've wasted that whole process, that whole energy dissipation, that whole cost. So it's really trying to do things more efficiently and more economically, not just financially, but across the board.
Thank you very much. So back to Ffion. I mean, for the audience here, what would be your key takeaway message for them to go home with, from your perspective?
I think from my perspective, and I'm learning more about it as well, is that satellites are really important and really crucial for the data that we need to collect to make Wales more sustainable and to look after our oceans and environments. And they're really great at what they do, but I also think if we could use some key data points from things like our microvessels and give real ground truth to validate these first of all, so people are more willing to trust them, and then also down the line we can improve these weather forecasts and really important things for our sustainability.
Cool. And Jeremy, one thing for the audience to take away?
It's quite niche, but one of the things that gets asked is, well, what does Wales do that is better than anyone else? And actually, Wales has more of its land mass recognized by the International Dark Skies Association than any other country in the world. And the important thing to recognize there is that dark skies don't necessarily mean no light pollution. It means that it's managed light pollution, and it's managed in the context of human habitation. So that's one thing where Wales is number one, and we should be proud of it.
Super. And Andrew, key takeaway?
Yeah. My key takeaway would be 24% of the Earth's energy is expended on making things. Now, not everything, but the vast majority of things that we make on Earth today could be made better in orbit. And so, Spaceforge and others are really working towards moving on to the sort of the next industrial revolution that's going to be happening in space. And this time we want to make it a clean industrial revolution.
Super. Okay, so I'm now going to hand over to questions, and I'm sure there's lots of questions. Are there any questions online? Better in person.
So, well, a question for each of you, but what would you think is your biggest challenge to achieve your net zero targets or your environmental targets?
Yeah. Well, certainly, we've got a lot of challenges in front of us. Designing, building, manufacturing satellites. We've already got one launch failure under our belt, and we launched on the Virgin Orbit Cornwall launch, unfortunately. So I think, everyone says space technology is hard, and I really reflect what Jeremy's saying in terms of we need to do more testing. We need more test facilities on Earth, and particularly in Wales, to help support that. It's a really big thing. So for us, the business is clear. What we need to do is clear. We need to sort out the regulatory environment to be able to regularly go into space and come back down again to bring these new materials, and then work out who's going to pay the taxes on it, because it's jurisdictional questions. But with all space technology, the challenges are all in the development of technology and testing it. And Jeremy.
Thanks, Andrew. I would certainly support the comments around regulation and the need for regulatory development. Funding is an obvious one that is one there for all of us. But I think one that precedes that really is a focus, a singularity, and a consistency in messaging. So it's about articulating the message about space in Wales, what we stand for, what we represent, and why people should invest in space in Wales. And that, I think if we can get that message across, then we'll have a very bright future.
Fine. Should we ask for any more questions? I'm just thinking. Yes. Is there a mic? Oh, sorry. I was past. Sorry.
Is there time for two questions, or is it just going to be me?
Yeah. Answer. Do your question. Yeah.
Thank you. Chris Bailey, Swansea University. Do you think there's going to be sort of a waiting game for the cost of per kilo to space coming down, like with the likes of the development of SpaceX's model, reusable rockets, and that driving that price down as much as possible? Is that going to make things easier over time, or is it a case of doing as much as you can now to develop the processes and the materials with a view to capitalizing on that later?
Cost of launch has come down a lot in the last 20 years. We're sitting on average. 20 years ago, it was about $20,000 per kilogram. If I bought a whole Falcon Heavy, which I can't do today, it'd be more like $1,000 per kilogram. The launch cost has come down, and it'll come down further, and that's great. The cost of space is not launch. It's a bit of a misconception. We did an analysis previously. The cost of the design, build, and test of satellite hardware is about $300,000 per kilogram for an operational satellite. So usually in the space mission, launch is less than half of the cost of the whole thing. Now, how do we get that cost down? Why these satellites cost so much? And part of the reason is lack of availability of test facilities. We've got big queues we have to wait for, and there's only a few specialist facilities, certainly in the UK, so we need more of those. But mainly it's because when you're designing a satellite that's going into orbit, and you can never touch it again. I would say, if you would design a car the way we design satellites, where you, once you got your car, got delivered to you, you could never refuel it, never take it for an MOT, never take it to a garage. That car would have to have, a fuel tank the size of a swimming pool, 3 engines, 6 wheels, and only drive about 3 miles an hour. And that's where we are with satellite technology at the moment. And one of the things we're developing at Spaceforge is the ability to bring satellites back, make the satellites fully reusable. And then you have something interesting. If you can bring whole satellites back, you can refurbish them, you can upgrade them, you can salvage them. Yeah, exactly, yeah. So the cost of launch has come down, but the cost of return has not. We're actually paying more these days than we were in the shuttle days. The shuttle is the most cost-effective way of bringing things down. So, yeah, it's the return aspect. Once we crack that, the price will come way down.
Thanks, Andrew. Good answer. Do you have a...
Yeah, thanks. I have a quick question for Jeremy. Once Spaceport Wales is operating, I heard during the earlier intro and some of the other answers to other questions, you mentioned companies that I'm not familiar with, but I'm guessing they're UK-based launch companies or rocket makers. And I'm just curious, is there any chance of, like you mentioned, maybe buy a Falcon Heavy or whatever? Like, could Spaceport Wales have a rocket that was made by SpaceX or some other country, but being launched from and returning to Spaceport Wales?
Yeah, so we're into the whole sort of launch dynamics from the UK there. So there are 2 types of launch that the UK's been looking at: vertical launch and horizontal launch. Vertical launch from the north of Scotland, and horizontal launch from Prestwick, Snowdonia, and Newquay.
What do you mean by horizontal launch?
Anything that isn't vertical launch, really. So all of the novel forms. So it could be a mothership that goes up, like the Virgin, Orbital, or it could be other novel forms. It could be a rail launch system, that shoots it up at an angle.
Right.
Really, for orbital launch, this comes back to regulation. You need to make sure you have a safety footprint that is such that if the rocket breaks up in the upper atmosphere, that the debris field doesn't land on areas of population. And so really for horizontal launch, as with Virgin Orbital, that really means you need to take off from the UK and fly either up towards the poles or way out into the mid-Atlantic. And that sort of takes away a lot of the competitive advantage by having to do that. So our view is, what we've got on our doorstep is a managed range, missile test range out over Cardigan Bay with unlimited ceiling, which has a safety footprint such that you can scrape the edge of space. So you could do a ballistic lob within Cardigan Bay and be sure that if anything were to happen, that debris field wouldn't fall on Wales, it wouldn't fall on Ireland, it wouldn't fall anywhere else other than over the water, and that obviously has its own environmental issues, but from a human safety perspective, the risk is minimized. So that's where we're focusing on test and really looking at all of the aspects of test from low altitude, high altitude, near space, basically up to the Kármán line, so you get the full effect of being in space without actually having to go into orbit, and you de-risk capabilities, and then you go somewhere else to do the orbital launch.
Thank you. Happy with the answer, yeah? Cool. I like the spin launch, by the way, the catapult. Are there any other... Oh, yes.
Hello, Ffion. How do you see your technology working with the likes of GNSS reflectometry data or from satellites? Does it complement or compete?
I think both. I think, initially I think it's to complement and to give people a bit more trust in satellite observations. And then I think further down the line to complete it, to fill in gaps. Satellites can't observe everywhere, and they can only observe during certain periods of time, and cloud coverage, they can't observe at all. So I think then that's when our vessels will come in and be able to complete the data that the satellites are collecting.
Any more?
Thank you. This question is for Andrew Bacon about SpaceForge. I know that one of the areas that SpaceForge is focusing on initially, as you mentioned, is materials that are easier to manufacture in microgravity, or in where the high vacuum or ultra high vacuum is an added benefit. So like crystalline structures, like maybe silicon wafers, microchips. I'm curious, are there other types of materials or products that you could name, that might be interesting examples of things that would be easier or more cost effective to produce in space, or maybe that you can produce them in space in a way that has lower environmental impact on Earth?
Yeah, it's a good question. So there was one particular market that was the inspiration for my co-founder Josh and I. So before we started SpaceForge, we heard about it and thought, oh, okay. So the one people tend to talk about when they think about in-space manufacturing for Earth is Llewellyn optical fiber. So back in the 50s, I think it was, there was a competition going on between silica fibers and Llewellyn fibers. And Llewellyn, is a fluoride-based glass, but it's quite a complicated alloy. And everybody went, oh, these Llewellyn fibers, they'll be great because they got a bandwidth that means they can get about 100 times the data down them than silica fibers. But ultimately, they lost out to silica because whenever you made these Llewellyn fibers, because they were a complex alloy of gases, various different gases, they came out cloudy because they didn't mix properly due to when you mix materials of different densities in Earth, what happens is, the high density stuff sinks at the bottom and the low density stuff rises to the top. So that was that for about 50 odd years until some very bright spark said, why don't we try this on one of those parabolic flights, the vomit comets as they're affectionately known. And they managed to extrude about 1 centimeter of this material, and they showed that it came out perfectly clear. And it was just 1 centimeter material, but they basically cracked it because when you're in microgravity, you don't have this buoyancy problem. There is no up, there is no down. So then they went on a 5-year journey. So they started the company called Made in Space, where it took them about 5 years to get it on the space station. But yeah, they did manage to finally pull out about 300 meters of fiber. They then got bought by create this mega structure called Redwire now. They seem to have got a bit distracted because they're doing work with NASA on in orbit manufacture for space with making big antennas. But other things they have done is ceramic turbine blades. So they've extruded ceramic turbine blisks on the space station. And why is that important? Because if you can, turbine blades are currently made out of superalloys. And you have a problem which is, well, one is if they crack, you kind of have to replace the whole blade. But if you could make better, stronger blades, you can make it in such a way that you can remove them. And so they theorized that you can make these turbine blades in space. And if you did, and you put them in an aircraft engine on Earth, they'd be about 10% more efficient. Now, 10% more efficient, if you apply that to all the aircraft currently flying today, that is, that is 80 megatons of CO2 per year, which is about the equivalent of, I'm trying to remember my numbers, Angola, I think? Pakistan. It's equivalent of Pakistan. So
Is that efficiency because they're ceramic blades instead of metal blades and they just weigh less?
Yeah, they're way less and you can make them slightly bigger. So the efficiency of an aircraft is down to the size of the engine, so you can make them better. So that's just a little thing. Now, you think, oh, hang on, I mean, how many turbine blades could you make in space? Well, to outfit the turbine blades for every aircraft on the Earth would take about 10 Starship flights. So it's doable. So, that's an example of something which, even though the value of, it's going to be quite expensive, a whole Starship flight to bring them back down there, but the value in the fuel savings, even to the aircraft operator, is way more than that. So, yeah, and as the price of launch and return comes down, the number of additional industries whereby space manufacture can support them will just rise exponentially until eventually it'll be everything. That's my thinking anyway.
that a question? Did I answer your question, by the way? Great answer, wasn't it? Yeah.
Are we moving sustainability off the planet into space? Because when you start talking about transference of manufacturer, suddenly you get loads of other businesses in space, other different products. Are we creating more of a problem of things in space? Are we just transferring the problem?
Great question, isn't it? And I guess it's around that, what you call space debris, or cleaning up space is is what Issa would say. Trying to think who wants to answer that one.
I have a short answer to that, and I'm happy to have, but which is the thought experiment I always go through is: would I rather strip mine an asteroid or the Amazon rainforest? Because the materials are the same. And personally, I'd rather strip mine an asteroid because nothing lives there. So from a sustainability point of view, the near-Earth space is dead, the moon is dead. Like, if we're going to pollute anything, let's pollute things away from our very fragile, important ecosystem. It's a personal opinion. You may not agree with it, but for me, there's way more. Effectively, the resources of space are infinite. The resources of Earth are not.
Making competition out of space, Jeremy. Do you want to talk about that proliferation of space?
Again, just picking up on one small point, which is the one around space debris, and again, our ability to at least understand what the problems and what the issues are, and perhaps be able to do something around management. So the ability to identify and track debris in space is a big issue. A number of tracking stations around the world have been developed to look at that. But again, the more eyes you have on the problem, the better data you have, and the more you can do with it. So one of the things, again, that we're looking at, and which is enabled by dark skies, is a laser tracking station that would allow Wales to have an indigenous capability for the tracking and monitoring of space debris, and using that data then to support the environmental monitoring that is done across other academic institutions.
And Ffion, you're relying on things being in space, I guess, even for you collecting data. Do you want to comment on how you need?
Yeah, definitely. I think without satellites, we're not even able to use our micro vessels. We can't talk to them. We can't tell them where to go. We can't gather the data that we need in our oceans. And about space debris as well, we've got all this debris in our oceans as well that we're not able to sort out. And it's kind of crazy. A way that we actually collect this data right now is also by chucking these balls of plastic over, and when they drift away from where we want to collect data, we just leave them out to pollute the oceans, and that's one of the reasons we want to make these vessels to come back to us. But I definitely think the move to reusability with Spaceport is really, really important.
Before we sum up, I think we got a few minutes. One more question.
Hi. Thanks, everybody. I have one question about going back to space debris. Do you think that there is an obligation on every party that is involved in space launch to invest in space debris, in the debris recovery, first of the existing debris, and secondly, in the debris that they create?
Thank you. Yeah. Space debris is definitely a growing issue that we need to address as an industry. Our specific approach is we are 100% the satellite we launch, we bring back. We're not leaving any part of it out there as debris because, we want to keep using this orbit for the next 1,000 years. So it's not a good idea to leave debris behind. And certainly when, we're moving to reusable satellites as an option in terms of being able to, I said to the gentleman over there, if you can bring them back, you can refurbish them, you can upgrade them. Once you start have that ability, everyone's going to want to do it in terms of even your telecoms constellations, they're going to want to come back to refurbish and refresh because ultimately that's how you get more performance out of your system. You'll be able to reduce the cost over time if you can actually do maintenance on these things. In terms of how does the current industry, should they pay for it, or there's a real problem because space debris collection is unbelievably expensive. I mean, the head of Iridium, Matt Desch, came out and said, "Oh, we'll charge $10,000. We'll pay $10,000 for someone to return our satellite." And the satellite return companies are like, "That's going to cost like 10 million." So, a couple of order magnitude, please. So, it's something. I mean, personally, well, I should say, as a company, we're committing to having no debris that lasts longer than 5 years. Really, we want to generate no debris at all. I think that does seem to be the sentiment of where the industry is going, that, sub 5 years rather than the 25-year rule. It's not a rule, but most countries to subscribe to it. That 5 years is starting to become the norm for when you have to get it back. So, there's a lot of satellites up there, and we need to get to a regime of where we're bringing them all back. Whether we're bringing them all back down to Earth and reusing them, which I think is the preferable because it makes more economic sense than just burning them up in the atmosphere. Because eventually, if you burn up all the satellites in the atmosphere, that's a lot of aluminium releasing into the atmosphere, which is not good for it either. So, we really need to get to a part where we're bringing it all back home, I think.
Quick follow-up on that. Doesn't that start to impact the cost of return? Doesn't that start to impact on the algorithm that your business is built on then, in terms of the cost saving versus cost benefit analysis?
Yeah, absolutely. I mean, the way that number I gave before of $300,000 per kilogram to design, build, and test a kilogram of satellite, that is because we don't get it back. That is because you have to do all the analyses and the over-engineering. In space, we generally have dual redundancy and everything. We have to double it up to make sure it lasts a lifetime. So you're duplicating. You've got two computers, you've got two power supplies, two sets of batteries. And that more than doubles the weight because you have to accommodate the switching systems between them, the intelligence that switches between them, and the additional structure to go around them. So if we can get to a period of where we can reliably bring them back, you don't need all that redundancy. And you can, when you think about refurbishment, it's a way of increasing life without spending lots of extra resources to increase lifetime. If we didn't refurbish aircraft, there wouldn't be much of an aircraft industry these days.
And then maybe you can continue the conversation afterwards on that one. It's quite a deep one. But I think I'd like to get one more question in. Did you have a question there?
Again, it comes back to, I think, is this leading to world legislation of space? Because one country thinking isn't the same as as another country or a private company. So through work undertaken with future flight projects, it's interesting seeing how sort of like governments and private companies think about space and how they're going to use it and operate it. Is it just, again, that transition from planet to space? But the question really is, do you think we're going towards legislation? If you want to have that kind of renewable breakdown, being able to do the flights going up and back, etc., etc., I can't necessarily see every country involved in space exploration necessarily having the same viewpoint, because profit and economy always comes into play.
Yeah, you have to make it worth their while to bring it back, and that's for me is why if they can bring it back and refurbish it and it makes the cost lower, then you have a business imperative to bring stuff back. And it's, I don't know. I mean, every country, as you say, is different. We don't all agree, but there does seem to be a very core sentiment growing in that we have to solve this as a problem. It can't go on as it has been, otherwise it's just going to get worse and worse. So, but Jeremy.
I think just to add to that, there are some international standards already. They need to be developed and refined to recognise where the industry's going. And the key point in all of that is if you have regulation, you also have to have enforcement. And that's the difficult bit.
That's fine.
Not really. I mean, I think about space, but I think to bring it back to marine again, I think it's the same for us. The legislation for autonomous vehicles out in the middle of the ocean, it's still not there. So I think it's quite a complex thing that will be dealt with in the future, I'm sure. But yeah, I think just raising awareness and actually having talks about it and seeing what people are doing, it's really interesting.
So I think we're on time now. So I guess summing up, very interesting. Thank you, our panel. I think what we heard about is space does enable prosperity, especially in Wales. We value in our people as well and our planet. So we talked about the skills and bringing the new generation on. I guess respecting our planet, but also respecting space as well, which I think was some of the last questions. So thank you very much. And thank you. If you give a warm applause for our panel.